Hey everyone, so today we are starting 1.4, which is kind of our intro into learning angles, more specifically angle measures. So let's get into it. So first thing we need to think about is array. Now we've talked about a line and a segment, now we have array. And array is something that's kind of like a part of a line, but then it goes on forever in one direction, but then it stops in another direction. So it has a beginning, but does not have an end point. And so this right here is an example of array. This would be called array AB. Now we've talked about segments and lines, and we've talked about how you could have named it line AB or line BA, the order didn't matter. But with rays, you have to start the name with the endpoint. So if I want to name this, I say it's ray AB. And notice the notation where it's just a dash with an arrow on one direction. And make sure that whatever the ray is, the endpoint is always in the beginning of the name. So if I was to draw in another ray like this and throw an X and a Y, that would be ray XY. And it has to start with X because ray X is the endpoint of that ray. And so when we talk about angles, angles are two or more rays kind of combined together. So an angle is formed when two non-collinear rays that have the same endpoint. So if you imagine we have one ray just like that, and then you throw another ray in that has the same endpoint, that's forming the angle right here. And so now we have to think about how do we name this angle, because if you look at the rays, it's ray AB and ray AC. But if I want to name the angle, you want to name it where the vertex is always the middle term. So when I'm naming an angle, I either have to use all 3 points, or if it's only one angle in the diagram, I can use what's called the vertex of the angle. So I can either start at B and work my way to A and to C, or I can start at C and work my way to A and then to B. So you're always starting at like what's called out on the ray, and then you work your way to what's called the vertex, and you make your way back out to the other ray. So one way to name this angle is angle BAC. So again, I start at B, I go to A, I go out to C. And the reason we name it that way is so when we put that name down, someone can easily find that angle within a diagram, because they would start at B, they would go to A, and they would go out to C. That's why that would be angle BAC. I could also name it angle CAB. Start at C, go into A, go back out to B. Notice it's still describing the same path, it just has a different starting point. Now if there's only one angle, so in this case there's only one angle, if I drew another ray in, there'd be more angles. But if there's only one angle, you can also name it using what's called its vertex, angle A. So that middle point right here. And so the parts of the angle are the sides, which are the rays. So these are the sides of the angles, the rays that make up the angle. And there's also called the vertex. The vertex is the common point of the rays. So that common endpoint. All right, and so whenever we name an angle, you can either name it using 3 points, or you can name it using the common endpoint or the vertex. Now you can only name the angle by its vertex if there's only one angle present. So as soon as I throw another ray on here like that, I could not name it angle A. And the reason is because if you say angle A, you don't know which angle that you're talking about. And you'll see what I'm referencing when I say that. in the slides to come. All right. So let's take a look at this diagram right here. So let's rewind 1 second. And when you look at that diagram, think of what are the ways you can name this angle. There's 3 ways you could name this angle. So go ahead and pause the video and think about it. So one way I can name this angle is XYZ, angle XYZ. So that's the symbol for angle right there, by the way, in front of that X. So I can go to X, go to Y, go out to Z. Another way I can name this angle is angle ZYX. Even though I'm switching the order, it's still the same angle. And because there's only one angle present, I could also name this angle Y, because there'd be no confusion if I said angle Y, because there's only one angle within the diagram. But if I throw in another ray, the number of angles now changes. So when I look at this now, I still have that big angle XYZ, but I also now have this angle here and this angle here. So there's actually 3 angles now within this diagram. So the answer to that question is there's 3 angles. So we need to name the other 2. So the other 2 are angle XYW and angle WYZ. Now remember, both of those names could be flipped. So I could say angle WYX, or I could say angle ZYW. Once I throw in this extra ray, this ray right here, once I throw that extra ray in, I can no longer just call this angle Y. Because if I were to say angle Y, no one would know which angle I'm talking about. So that is why once there's multiple angles with the same vertex, you have to name it using 3 points. So angle XYZ, angle XYW, angle WYZ. So naming angles is super important because we're going to be doing it a lot this year. So next I'm going to briefly talk about measuring an angle. And the first thing I want to talk about is when we look at a circle, remember how much of a circle degrees in measure, right? So when you think about doing, I think snowboarding or skateboarding, if you flip around so that you're facing one direction, then all of a sudden you flip the other way, that's called a 180. So you're taking one direction and you're flipping to the other direction, so 180 degrees. But if you flip all the way around, that's 360 degrees. So angles are measured in degrees based off the circle measurements. So as soon as I start throwing in, sorry, my video is kind of lagging a little bit, but as soon as I throw in what's called a protractor to measure angles, now I have to think about putting it up and measuring it correctly. So here's how you would measure using what's a protractor. So let's throw this random angle in on this diagram. Now you always want to line up one of your rays with this bottom point down here. Okay, so we take our vertex and we line it up at that center dot of a protractor. We then also line up one of our rays with this bottom line of this protractor as well. Now if you look at a protractor, if I go this direction, there's 2 measurements I can read. It goes 0 to 80, but then it also goes 170 to 100. If my ray is starting right here and I'm opening in this direction, I want to start reading it at the 0. So I would read the inside number right there. If my ray was on the other side, and I was opening in this direction, then I would read the outside number. So for the sake of this problem, I'm reading the inside number because I'm opening right to left. So if I wanted to measure this angle right here, I would go up, 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 up to that point. That angle is 80 degrees. Now let's flip it. Let's say I get rid of all this information, and now I'm measuring it in a different way. So now I'm starting on the left-hand side and I'm opening up to the right. That means I'm going to read the outside number. So that means that this angle is 130 degrees. Okay? While we're distance learning, guys, I don't know how many angle measures we're going to do using protractors, but it's always a good thing to kind of just review and show you how it works. So degree angles are measured in degrees. It's all based off a circle, which is a 360 all the way around. So again, if I look at a circle, it's 360 degrees all the way around. And then the protractor is able to measure half of a circle, so 180 degrees. All right. And then most angles that we're going to measure are going to be 180 or less. Moving on. So classifying angles. So this is a very important part. We're going to learn some very fundamental angle names just now. So we're going to have what's called right, acute, obtuse, and straight. So again, right, acute, obtuse, and straight. So a right angle, which I think most of us already know, is an angle that has a measure of 90 degrees. And so that is a right angle. So if I were to look at it in the diagram, it's either signified by that red little box, but just know that any angle that measures 90 degrees, we call that a right angle. Up next we have an acute angle. So acute angles are all angles less than 90 degrees. So that would be anything less than 90. After acute, we have obtuse angles. So obtuse angles are anything greater than 90 but less than 180. So here's a good visual of what an obtuse angle might look like. So when you think about it, remember a 90-degree angle goes straight up, kind of like that. So anything past that, that's going to be obtuse. And then the last one to know is a straight angle. And that's when the measure is 180 degrees, or a straight line. So for this one here, the angle measure is a straight line, so also known as two opposite rays, two rays that are traveling in the complete opposite direction. That right there would make a straight angle. All right, so again, right is 90, acute is angles less than 90, obtuse is angles greater than 90 but less than 180, and straight angles have a measure of exactly 180. There's no special names for anything past 180. So I want you to take a look at this diagram. And this is just a good example to test the skills of what we just talked about. So classifying angles. So part of this is also being able to find the angle that I'm talking about. So I say angle BAD. Start at B, go to A, go out to D. So I'm talking about this angle right here. All right, and so that would be an obtuse angle because it's greater than 180. Angle EAC. Start at E, go to A, go up to C. Well, I notice I have this right angle symbol, so that would be a right angle. Angle DAC. Go to D, go to A, go out to C. That's less than 90, so that's acute. BAE, B to A to E. AB and AE are opposite rays, so that would be a straight angle. And then CAB, C to A to B. Now this is kind of like next level. Now I know that this angle right here is a right angle. I know that this is a straight line. So I know a straight angle is 180. I know that a right angle is 90. So that means that angle CAB is the difference between those two. So 180 minus 90, that is 90. So that means that angle CAB is also a right angle. All right. Now, that's what you kind of have to remember, that anytime, guys, you have one right angle made with two lines, that means that all the other three angles are also right angles. Okay? So just kind of a concept to always keep in the back of your mind. All right, last slide. Angle bisector. So remember, we talked about segment bisector a little bit last week. So a segment bisector, if I have a segment, and I know that this segment is bisecting it. Bisect means to cut in half. So I know that the segment on the left is the same as the segment on the right. So an angle bisector does the same thing. It's a ray or a line or a segment that cuts an angle into two congruent angles. So it cuts the angle into two angles that are the exact same measure. So if I was to say that angle BAD is congruent to angle CAD, so notice it's congruent. Notice I'm now setting up the markings showing angles are congruent. We talked about how you use markings to show segments are congruent. You do the same thing with angles. So if angle BAD is congruent to angle CAD, then I know that segment or ray AD is an angle bisector of BAC, BAC being the entire thing. Now I know it's a little bit confusing, but it's really simple. Like if you know something's an angle bisector, then you know that two angles are being congruent. If you know two angles are congruent, then you know you have an angle bisector present. Okay? So let's look at our last little diagram here. My video's lagging a little bit, kind of getting all the information out to you. There we go. So it says ray KJ and ray KM are opposite rays. So if they're opposite rays, I know they're making a straight line. And if they're making a straight line, I know that that measures 180. And then it says that KN, which is KN is right here, bisects JKL. JKL is right here. Okay? So if JKN is 8x minus 13, and NKL, which is here, is 6x plus 11, it's asking us to find the measure of JKN, which is, again, this little one in red. Now remember, they told us that this was an angle bisector. So if that's an angle bisector, that means that these two angles are congruent. If those two angles are congruent, then their equations should be equal, because remember, congruent means same size and same shape. So that transfers to angles as well. So our setup would be 8x minus 13 equals 6x plus 11. And then from there, I need to solve for x. So I'm going to subtract 6x, and then I'm going to add 13. So then I get 2x equals 11 plus 13 is 24. So that means x equals 12. Once I know x equals 12 and I'm trying to find JKN, I plug it into that equation over there. So 8 times 12 minus 13 is going to give us our angle measure. So then 8 times 12 is 96 minus 13. 96 minus 13, 96 minus 10 is 86, minus 3 more is 83. So our final answer is 83 degrees. So biggest takeaway, guys, for this lesson is knowing how to name an angle, how to find an angle based off its name, knowing that you have right, acute, obtuse, and straight angles, and then understanding what an angle bisector is. Let me know if you have any questions.